Hey, Algebra 2, welcome to section 8.5. Here's our first section for the second half of our quote unquote year in Algebra 2, right? This is the second half of the, actual time-wise semester, but, we're going into the second half of Algebra 2 now that we've done the first half, okay? So we're just gonna keep on trucking along. We have the rest of chapter 8 to go. Then we're going to bounce back to chapter 6, then go to chapter 7, and then we're going to bounce all the way to trig, okay? Just to give you a little bit of a trajectory of kind of what to expect for the rest of the rest of our time in Algebra 2, all right? So I'm going to keep on saying this, all right? But I'm going to say it until maybe it kind of gets to you. If you're needing help, you need to come and get some help, okay? Come to my after school hours, come to my before school hours, come to the advisement study labs, ask questions during class. There are, like I've mentioned before, there are plenty of opportunities for you to get help on this stuff. There's no excuse for you to kind of just at the end be like, well, I don't know how to do this. Well, did you come and ask for help? Right? So make sure you're coming and asking for help if you need help. All right. So let's get into it. At 8.5, we're going to add and subtract. We multiplied and divided it in 8.4. Now we're going to go ahead and add and subtract to the rest of our operations. Okay, so the plan is to remember how to add and subtract fractions with either common denominators or uncommon denominators. Okay, so kind of taking a step back and seeing how did we do it when we, we're working with just numbers and not expressions. Okay, so then we're going to be able to find common denominators for rational expressions. So how do we do that when now there's variables involved? And then we're going to do what 8.5 tells us to do, add and subtract rational expressions with either common or uncommon denominators, okay? So as a recap, how do we add fractions when the denominators are the same? Well, for example, what do we do with 3/5 plus 7/5? Well, we go ahead and we're allowed to add these right away because our fifths are the same, our denominators are common. So I do 3 plus 7 over 5. I don't do 5 plus 5. I just add the numerators. And what do we get? Well, that's 10/5. Oh, and then conveniently, I can simplify this a little bit. That's actually 2. Okay, you won't always be able to simplify it, but remember how this is how we add fractions. It's the same thing if I did 4 over 7 minus 2 over 7, right? This time it's subtraction, so I did 4 minus 2 over 7. Okay, my denominators stay the same. They do not change. They do potentially when we multiply and divide, because we multiply straight across with our, multiply the numerator by numerator, denominator by denominator. But in this case, the denominators stay untouched. Okay. So now let's add or subtract in example 1. But now we're going to involve expressions. Okay. So let's look at this first one. 7 over x plus 3 over x. Are our denominators the same? Yes. Okay. So what can I do? That's going to be over x, 7 plus 3. Add my numerators. We get 10 over x. Can we simplify this at all? No. That's our final answer. Okay, not too bad. Our denominator could just be one thing. In part B, our denominator has multiple objects in it. It's 3x squared, but I still have common denominators. I have 3x squared, 3x squared. So then I do 2 minus 1 in my numerator, right? Divided by 3x squared. The denominator does not change. 2 minus 1, that's 1 over 3x squared. Can I simplify this at all? Nope. This is also my final answer. Okay, not too bad. Let's ramp it up a little bit. 4x over x minus 2 plus x over x minus 2. Let's take a look at our denominators. Are they the same? Yes, that is correct. They are the same. Okay, so we have to be careful, right? We have an x minus 2 here and an x minus 2 here. If they differed by even just one thing, then they are not the same. We have to do something about it, right? So for example, if I had x minus 2 for this one, but then x plus 2, these are not common. Okay, for this, let's say that I had x minus 2, x minus 3, not common. Even though the x's are the same, not common. Let's say I had x minus 2 and y minus 2, not common because these x and y's could potentially be different. Okay, they have to be identical for them to be considered common denominators. In this case, they're identical. So let's do what we have been doing. Okay, I can add my numerators, 4x plus x over x minus 2. Okay, what is 4x plus x? That's 5x over x minus 2. Can I simplify this at all? Nope. This is done. One more for our common denominators. So let's go ahead and do this. Our denominators are the same, x squared plus 1, x squared plus 1. But now kind of we have to be careful, okay? 2x squared plus x plus 1 minus this, okay? Minus this whole thing, not just minus the first term and then continue adding the rest. It's minus the whole thing, okay? So if it helps you, whenever you have kind of a longer, when you have a polynomial, instead of just one term like we've been dealing with, instead of like monomials like for these, if you have a polynomial, just wrap it in parentheses so that you know that this operation is applying to everything, okay? So equals 2x squared plus x plus 1 minus that entire quantity, 2x squared plus 2x plus 1, and that's all divided by x squared plus 1. Okay, let's do it. So 2x squared minus 2x squared, those are going to cancel each other out. They're simplified out. X minus 2x, x minus 2x, that's negative x. 1 minus 1, those also simplify each other out. Okay, so I just have negative x in my numerator, x squared plus 1. Can I simplify this? No. Okay, I could simplify if that second term in my denominator, so that 1 had an x attached to it, but it doesn't, so I can't simplify any x's out. Okay, this is all good. This is my answer. All right, hopefully that's okay. All right, this is an example with everything being the same denominator. Now let's dive into examples where our denominators are different. Before we do that, let's talk about how we did it with just numbers. So let's talk about maybe adding 1/4 plus 1/2. Okay, this is not 1/6, right? Big no-no. All right, so how did we do it? Well, I have 1/4 plus 1/2. I need to add the same thing together. I need to have apples and apples, not apples and oranges, right? So I need to have the same denominator. Okay, well, how do I get that? Well, I need to find the least common multiple of 2 and 4. So what number does both 2 and 4 go into that I could potentially write it as, right? And it has to be the smallest one. So 2 and 4. Okay, what's my least common multiple for 2 and 4? That's going to be 4, because 4 and 2 both go into 4, and it's the smallest one. All right, so for this one, it's easy to see that it's 4, right? And if it's 4, if my least common denominator is going to be 4, then what do I need to change? I need to change the 1/2. So I got to multiply by, what do I do to get it to 4? Multiply by 2 over 2. Okay, and that's going to give me 1/4 plus, when I multiply this out, we get 2/4. And when you add these, we get 1 plus 2 over 4, and that's 3 over 4. Okay? So then now for that one, it wasn't too bad, but let's try it for maybe a little bit more of a complicated one. Let's do 1/3 plus 2/7, okay? So 1/3 and 2/7, I need a common denominator. Well, is there anything in common between 3 and 7? No. So I need to find the least common multiple between 3 and 7. Now, do they have any common factors when I think about 3 and 7? Well, they don't, because 3 and 7, they're prime, so they don't have any factors, which means that that's as far as I can go. So if that's the case, then I need my common denominator, my least common denominator, to have both. So I need 3 times 7, which is 21. Okay, so that's my least common denominator that I need. What do I multiply this fraction by to get the 21? It's going to be 7 over 7. What about this fraction? It's going to be 3 over 3. Okay, so then let's carry that out. When I multiply this first one out, I get 7 over 21 plus, this is going to be 6 over 21. Okay, when we add those together, we get 7 plus 6 over 21, which is 13 over 21. Okay, so that's what we get when we add 1/3 plus 2/7. Okay. One more just to kind of make sure it's kind of clear. Let's do 2/3 minus 1/12. Okay. And actually, let's make it a little more. How about, let me change this up a little bit. Just so you guys can see plenty of examples. Let's do 2/14. Just kidding. 3/14. Minus 1/10. Okay. So let's think about, okay, we need a common denominator here. Between 14 and 10. Well, what are these simplified down to if I factor them down? 14 is 2 and 7. 10 is 2 and 5. Okay, so let's you can think about this if, let's say, you and your friend were going to go shopping. Okay, either you're going to the grocery store together, or either you're going to go to the mall together. I guess not in this kind of state, but in the past when you've gone shopping with your friends before, maybe you're going to get something, like you're going on a shopping spree. Well, normally when you go, you have some stuff that you're going to buy, but your friend also has stuff that they're going to buy. And sometimes you might have stuff in common, but then other times you might just have completely different shopping lists, right? So in this case, let's pretend that this is 14's shopping list. It needs a 2 and a 7. And this is 10's shopping list. It needs a 2 and a 5. Well, you're not going to leave the store until hopefully you both get the same stuff, right? So what's going to be your shopping list combined? Well, you have this 2 in common, okay? So that's going to be part of your joint shopping list, okay? The 10 needs a 5, so that's going to be part of the shopping list. And the 14 needs a 7, so that's going to also be part of the shopping list, okay? So what's your final shopping list? It's 2 times 5 times 7, okay? 2 times 5 is 10, 7 is 70. Okay, so that's your final shopping list, right? For example, let's say that you really wanted to get a shirt and your friend also wants to get a shirt. So you know that you're going to have that in common. You know you're going to go to the same place for that. But let's say your friend wants also a video game, and then maybe you don't want a video game. Maybe you want maybe you want to go to the food court and get like a sandwich. Okay, so you both want a shirt, but then your friend needs a video game. So that's got to go on the list because you're not going to leave until your friend gets a video game. And then you're not going to leave until you get your sandwich. So all in all, you need the shirt, the video game, and the sandwich. Okay, so hopefully that kind of makes sense in terms of the common denominator. So we know our common denominator is 70. Let's get that here. Okay, so what do I multiply the 14 by to get 70? Well, remember, 14 is 2 and 7. So what is it missing? It's missing the 5. So I have to multiply by 5 over 5. What about our second fraction? I have 10. What do I need to get 70? Multiply by 7. Because remember, 10 is 2 and 5 is missing the 7. Okay, so what do we get here? We get 15 over 70 minus 7 over 70. Okay, 15 minus 7, that's going to be 8 over 70. And then can I simplify this at all? Yes, I can actually divide both numerator and denominator by 2. Okay, 8 divided by 2 is 4. 70 divided by 2 is 35. Okay, and that's our final answer. All right, hopefully this sounds okay. Let's go ahead, meet me in the next video, and we'll actually apply this stuff to rational expressions and not just fractions with numbers, okay? I'll see you in the second part.